Okay, we want to find the general solution for this differential equation above. As you see in here, we want to first see what is the order of these differential equations so we can approach it differently and specifically. As you see in here, we have the term of d2y by dx2 in here, which means this is a second order differential equations because we are taking derivative of y with respect to x 2 times. So this is a second order differential equation. For a second order differential equation, we should find two answers and combine those two answers together. The first answer is the homogeneous answer, and the second one is just the particular answer. And if you combine these two answers together, you get the general formula and general answer for this equation. So we want to first find the homogeneous answer. If, as you see in here, this equation is not homogeneous because it is equal to 3x plus 2. If it was equal to 0, that would make it homogeneous. So I'm just going to rewrite it, d2y by dx2 plus 2 dy by dx minus 3y equal to 0. So I already made this equation homogeneous in order to get the homogeneous answer. Now, we know based off the second order differential equation formula, the general answer is e to the power of mx. And in order to get the characteristic equation, we just substitute e to the power of mx, which is the general formula, into this equation. That would get us m to the power of 2 plus 2m minus 3 is equal to 0, which is the characteristic equation of a second order differential equation. Now we can factorize this equation and say this would be equal to m plus 3 times m minus 1, which would be equal to 0. We did this factorization by the fact that the multiplication of these two numbers in here that I wrote would be equal to minus 3, and the summation of these two numbers would be equal to plus 2. So we get two values of m for m in here, which is m is equal to 1 and m is equal to minus 3. Now we want to write the linear combination of the answers, so we get the homogeneous answer in here. So the homogeneous answer would be equal to a times e to the power of x, because we are substituting, if you see in here, we're substituting the m is equal to 1 into this equation. Our first answer would be e to the x. Our second answer would be e to the minus 3x. Since we want to find the linear combination, we just write a and b as our coefficient, so we can actually combine them. So the second one would be e to the minus 3x. Now, in order to find the particular solution as well, we're just gonna say that the general formula for y would be equal to ax plus b. Since our f of x is equal to 3x plus 2, our general formula for the particular solution would be ax plus p, which is the more general format of 3x plus b. Now I'm just going to substitute ax plus b into this differential equation in here. So it would be the second derivative of ax plus b would be equal to 0 plus 2 times of ax, 2 times the first derivative of ax plus b, which would be equal to a minus 3 times y, which would be equal to ax plus b, which would be equal to 3x plus 2. Now, if I rearrange the equation in here, it would be minus 3ax plus 2a minus 3b, which would be equal to 3x plus 2, which I can say that the coefficient of x in the left hand side and the right hand side would be equal. So that means minus 3a would be equal to 3 which would get us that a is equal to -1. And on the other hand, we say that 2a minus 3b would be equal to 2, which we already know a is equal to -1, so this value would be -2. If I actually transfer it to the right hand side, it would be +4. So it would be b is equal to 4 divided by -3. Now, we got our particular solution, which is -x plus -4/3. Now we can rewrite our general formula, which is yh plus yp, which would be equal to our yh, as you remember in here, which was ax plus be to the power of -3x, and our particular solution is -x minus 4/3.